Alright, so if I was just thinking, let's look at the first one at a normal sine x. Hopefully you can remember. It starts at 0, goes up, goes down. Whoops, this looks really bad. Pretend I don't have the grid behind so you can tell it's not to scale. And it would go have an amplitude of 1, so it would go as high as 1 and as low as -1. But in this case, I'm looking at the amplitude and it's 5, so it's going to go as high as 5 and as low as -5. And in this case, usually for sine and cos, we have a period of 2 pi. But in this case, we have to divide by whatever the coefficient of x is. So in this case, the period is just pi. So I'm going to make this do a different colour so you can see. So this is going to be pi. That means this will be pi on 2. That means this will be pi on 4, half of that. So really I've got pi on 4, 2 pi on 4, and then 3 pi on 4. So you can see that point, which is a stationary point, will be 3 pi on 4, -5. This point, which is a stationary point, will be pi on 4, 5. This point, which is our 0, or our zeros are at 0, pi on 2, and pi. What did we have to show? So show intercepts, turning points, and asymptotes. No asymptotes there. Of course it will keep going, but I think we just had to show one period. So if I go over to tan, so my normal tan graph we know looks something like, and I'm sure I'll do this badly, like a cubic followed by a cubic, kind of like that. And in this case, we don't have an amplitude because it goes on and on forever, up and down. So it looks like we've got an amplitude, but we don't. And the period of any tan graph, the period is usually pi, but we need to divide by whatever the coefficient of x is. In this case, it's a third. So if I divide by a third, it's like timesing by 3. So 3 pi gives me a whole period. So if I just go from beginning to end, like so. So yes, it keeps going. Yes, it keeps going. But just from there to there will be one period. So let's say that's 3 pi. Therefore, halfway between that is 3 pi on 2. So here I've got 3 pi on 2, x equals 3 pi on 2 as my asymptote. And of course that will be 0. Do we have to put anything else in? No, we can find points. Oh, perhaps. No, I don't think we have to put anything else in. You could find other points if you want, but just practicing using amplitude and period, remembering for tan, it's pi over the coefficient of x. For sine and cos, it's 2 pi over the coefficient of x.